that when you're actually finding the coefficients of friction, there's so much play in what you're doing there, and the experiment's not a whole lot more sophisticated than what I was doing right there, other than they have better precision in terms of measurements. But there's so much imprecision in that angle, there's so much play in, I guess it would be called the error of the angle at which it starts to go, that ultimately I might have a coefficient of static friction officially at 0.7 and a coefficient of kinetic friction at 0.5, but in reality, if you looked at the distribution of data, this would actually be somewhere like 0.55 to 0.8, and this would be, say, 0.4 to 0.65. There's a whole lot of overlap. There's no reason to think that they would be different values. And again, I haven't seen evidence I haven't seen the published paper, I should say. But it sure seems to me that it should be obvious that you should be able to eliminate one of them clearly, but just waiting for that someone to come along and do the experiment. And again, for I think the third time, engineers have something that work. And physicists don't deal with it much. Questions on friction?
No more questions, but that one just seemed a little bit confusing than this one. But it's basically the same thing, right?
Yeah, there are a lot of similarities there. If this were 151 where we got more into the math of it, then there'd be a clear difference in how you approach problems between the two.
Okay.
But for 110, this is the way most textbooks do it.
Okay.
The slightly more sophisticated beginning textbooks will do this, and then they'll have a page on this, just sort of acknowledging its existence. All right, I'm done with 4. I'm not going to announce when the quiz is on 4 because we're going to do quiz on 4 and 5 together. So I'll wait till we're done with 5 before we do the quiz on both of them. But I'm guessing it'll be 2 weeks from today. And then the test probably a week after that. Not official yet, not written on the paper.
So you're gonna be like, I was just gonna say you're gonna tell us what's on the test, but you already let us know the questions from the bug chuck. We can discuss things.
It's on Blackboard, right? Okay.
Old tests are on Blackboard.
We
Some
should
of
be
with
checking-
solutions, more with some with answers. Some, I think I have 2 posted that don't have solutions or answers. But
We should be looking at old tests?
in preparation for the test, I would recommend it.
Oh, okay.
The master set problems for chapters 2 through 5 come from old tests, so you can also look at the master set problems. And I can't remember if I posted the solutions for the master set problems for this group. Since it's not required for a grade, I should be able to post them. It's just a matter of remembering at the right time.
And there's a whole section for old tests?
Yeah, if you go under, I think it's course doc or course documents,
Mm-hmm.
if you click on that, there should be, I think at the top says old tests. And you're looking for test 1. I think the first section is test 1, then there's test 4, then test 3, something like that.
Okay.
All right, chapter 5, we've actually done. I just didn't call it by the names. When we were doing force diagrams, I said forces come in pairs. We draw a weight acting here, we had a weight down here on the ground, we had normal force pushing between objects. That was the application of Newton's 3rd law, which is basically chapter 5. I'm gonna write out a more formal way of expressing it, then I'm gonna do a math abbreviation of it, and then I'm gonna talk about the common expression for Newton's third law. The one that I really want to avoid, but I at least want to acknowledge its existence. So, if object A exerts a force on object B, then object B exerts a force on object A that is equal in magnitude opposite direction and of the same type. I'm exerting a normal force on the floor is exerting a normal force on me. It is the exact same magnitude, just opposite directions. I'm pushing down on the floor is pushing up on me. Now the shorthand notation, which you may or may not be a fan of, the force on A from B is equal to the negative of the force on B from A. That's the shorthand of Newton's third law right there. And then the more common expression, I won't write down, but I'll say, for every action, there's an equal and opposite reaction. My problem with that is the word reaction means something different in everyday life than it does there.
Cause that's what I wrote down too.
Yeah, there was, I don't remember if I did the rant against that video I saw posted. Well, I'll rant again. I was looking around for a video on Newton's third law, something I could show to a class, and I came across these, I'm guessing middle school students, who posted this video of in a bowling alley, and there's a bowling ball sitting on, waiting to be picked up. The bowling ball had just gotten returned, and then one bowling ball hit the one that was sitting there, and that one that was sitting there then starts moving. Their misapplication of Newton's third law was, this ball hit that ball moved. No, that is not Newton's third law. Newton's third law would be, this ball hit that ball, and this ball hit this ball. They hit each other. Or, more specifically, ball A, or whatever you want to call it, we'll call it ball A. Ball A exerted a normal force on ball B. Ball B exerted a normal force back on ball A. That's Newton's third law. But everyday life reaction is more of a response than an immediate thing. If a ghost appeared in the room, a natural response would be, that is not Newton's third law. I heard a justification for a mass killing spree based upon Newton's third law, where someone said it was a natural reaction to what has been put on this guy, and not Newton's third law. Don't use Newton's third law. If you want to, the situation I'm not going to go into detail on, but you could make some legitimate justification for what this person did because of how this person was pushed, but it's not Newton's third law. How he reacts to what was being done to him is not Newton's third law. And yes, this is a lot wordier than the everyday expression, but this is more accurate. Let's formalize it slightly. A boy exerts a 5 Newton normal force down on that table. So, just imagine he has his hand on it. Whenever we're dealing with forces, it requires two objects and the actual force itself. So let's think about the two objects involved. We have a void and we have a table. We have our detail of the force right here. We have a direction, because force is a vector, so we have a magnitude and a direction. So magnitude and direction of the force. The application of Newton's third law, all we do is we switch the objects in the direction. So if this is true, then the following must also be true. A table exerts a 5 Newton normal force up on a void. We switch the objects and we change the direction, and then that is true. I think that's chapter 5 right there. That's what we already talked about, forces. Then he talks about the vector stuff, which we've already done, or at least in the 12th edition, 11th edition. Oh, that was easy. Any questions before we start talking about quizzes, tests, and neat junk like that?
So this is all we need, this is like basically it for chapter 5?
Yeah, I mean, the other stuff that
Everything
it
else
goes into, we already covered in chapter 2.
Okay.
Alright, so the quiz on 4 and 5, we'll make it 28th, and then we'll have test 1 on October 5th. Unless, if you're gonna express an objection, now would be the time to bring it up.
Like test one?
October 5th is what I wrote down over there.
Sorry.
I have the power to cross out if I have to. Now, the advantage to actually pushing things forward are that it's not like we're not gonna cover new material between now and the test. Some students like the test to be closer to when we finish the material. And so, if there's desire, I can move the test earlier.
So you're saying, so the new material that we may cover before the 5th is, would it be on a test?
It would not be on the first test. Typically, the next bit of material, I just have, I assess it through quizzes as opposed to a test.
And you said our quiz, we have that on the 28th?
Yeah, the quiz on 4 and 5. So next week, next Monday, or Tuesday, as people say today. Next Tuesday is quiz on chapter 3, chapter 4 and 5 quiz is the following week, and then the test is the following week.
Oh. Yeah, you were listening.
And class is not over yet, by the way.
Like October? Thank you.
Oh, you're I can read.
Yeah.
I'm sorry, I thought you were joking.
No, it's okay, you're good. It's okay.
And the test on the 5th is gonna be the cumulative of 3, 4, and 5?
2, 3, 4, and 5.
2, 3, 4, and 5?
Yes. But chapter 2 is forces, so it's not crucial.
Huh?
Chapter 2 is forces, it's rather quickly that get thrown in there. 4 and 5 would be lonely without 2.
Okay, cool.
clock is actually accurate, or as accurate as Verizon is. All right, so I'm gonna set up the problem for chapter 6. I suspect, well, maybe we'll get lucky, maybe we'll get past just the setup. I have some object A here that's going to crash into an object B. They're heading towards each other in my particular scenario. They are going to collide and then bounce. So they're going to basically hit somewhere around there, and then after the collision, they're going to bounce in opposite directions, although they don't necessarily have to bounce in opposite directions.
So it's like that thing when two people run at each other while they're holding those big bouncy balls and then they ricochet off.
Very much like that. So for those who need something more visual, with sound effects. All right. While they are in contact with each other, while A and B are in contact, there are three things that are the same for both objects. So while in contact, there are three things. Three quantities, I should say. Three quantities which are the same for both objects. But that's a statement, not a question. The question is, what are they? See if we can add a little bit of excitement here. All right. What's a quantity that's going to be the same for A and B?
Is there an A?
Pardon?
Oh, they were playing Hangman.
Oh.
Maybe acceleration?
Acceleration will not be the same, not necessarily.
Well, no, because they're going in the same direction.
That too. Dismissed. There we go. That's what I was looking for. All right, so I'm going to hand back quiz number 1. That was what that was for. Gotta remember. There's loads of quiz grades, so, you know, my system is set up so that one poor grade or one really good grade is not gonna make or break you. So there's loads of grades over the course of the semester, and everyone in here can make an A, everyone in here can fail.
Thanks for that.
And again, there's been only, I don't remember if this was in a video or it said it at some point, but there's been only one student I've had who's done every assignment, get a grade below a C. So,
Huh?
twice. So, do the best you can.
You said that's our assignment and still at a C,
Below a C.
below a C?
Usually the students who typically get grades at the end, the overall grade below C, are people who stop handing stuff in,
Oh,
stop showing up for quizzes, things like that.
okay.
Now, I was calling you Becca. Do you prefer Becca or Rebecca?
Oh, Becca's fine. Becca's okay.
Okay, right. So it sounds like you prefer the other. All right, so now I get to embarrass myself as I try to remember the answer. Gabby. All right. This one here. Yeah, that
should have put it on the other side. Sorry about that.
Yeah, Jesse. Maddie. Probably should have organized this baseball where people could do this. Let me stop this before I accidentally flash a